Hey there, I'm Saroj, a tech executive with over 10 years of experience building cutting-edge AI applications at top FANG companies and startups. Welcome to my channel, Artificial Intelligence Clearly Explained. Here, we simplify complex AI concepts into easy-to-understand explanations. Whether you're a busy professional or a curious learner, you'll find valuable insights and practical examples. Ready to dive into the fascinating world of AI with me? Let's get started. Today, we are going to understand what neural networks are. We are not going to use any math or jargon. We are going to explain concepts clearly. While computers excel at performing complex calculations like multiplying millions of pairs of numbers, they often struggle with tasks humans take for granted, such as recognizing faces in photos or understanding speech. The human brain consists of billions of neurons that communicate through electrical impulses. These neurons form complex networks that enable us to think, learn, and make decisions. Similarly, a neural network is composed of artificial neurons that work together to make predictions. Neural networks might seem complicated at first glance, but they become quite intuitive once you understand the basics. Let's break down their main ideas using a practical example: predicting the price of a house. Imagine you're a real estate analyst. You want to know how many dollars to list a house for. You have data on various houses, including their prices and features like the number of rooms, square footage, location, yard size, and age. For a new house you are listing, you know the input features of the house and want to predict the market value based on these features. For a moment, let's simplify this example by just predicting the price of this new house based on only one input feature, the number of rooms. We will ignore the rest of the input features for now. To predict the price of any house, you need to fit a line or a complex curve to this data set. Fitting a straight line is simple, but not that accurate, since it doesn't fully capture the relationship between the number of rooms and the price of the house. So we need to fit complex curves to get more accurate predictions. To fit complex curves or squiggles to data, neural networks are used. This complex curve or squiggle more accurately captures the relationship between input features and the output. Now that you know neural networks are used to fit a squiggle or complex curve to a data set, let's go back to our complicated example to predict the price of a house for this data set. We will fit a neural network to this data to predict the price of a house. A neural network is like a group of tiny calculators known as neurons that work together to make predictions. Each neuron takes one or more inputs, processes them, and produces an output. These neurons are organized into layers: the input layer, hidden layers, and the output layer. To create a neural network, we start with the input layer, which consists of the features of the house: the number of rooms, square footage, location, yard size, and age. Each of these features is fed into the neural network as input data. As the inputs move to the hidden layer, neurons in this layer start processing the data. Think of neurons in the hidden layer as estimating different aspects that affect the house price. For example, one neuron might estimate the affordability of the house based on the number of rooms and square footage. Another neuron might assess the desirability of the house based on its location. A third neuron might evaluate the condition of the house, influenced by its age and yard size. You might notice that the nodes have curved lines inside them. These bent or curved lines are called activation functions. Each neuron processes its inputs through this function. which determines the neuron's output based on the inputs it receives. The output layer takes inputs from the hidden layer and processes them to predict the price of the house. Using this neural network, you can now predict the price of any house. This process of using the neural network to make predictions is called forward propagation. The process of using the input or training data to fit the neural network is called backpropagation. We will learn more about backpropagation in later videos. When building your own neural network, one of the decisions you need to make is how many hidden layers you want and how many neurons you want in each hidden layer. This decision forms the architecture of the neural network. Thanks for watching. Did you find this video helpful? Watch more such videos here. Please like, share, and subscribe to stay updated with more AI explanations. Got questions or topics you'd like me to cover next? Drop them in the comments below.